So, hello, good morning, good afternoon. My name is Mark Thomas. I'm responsible for the discrete IGBT product marketing for Infineon. I'm based in Austria, and today I am here to talk about the latest releases of discrete IGBTs, which could be quite interesting for two focused segments for this presentation. What I would like to start with is basically which applications am I talking about for these product releases. So I start with the home appliance market and also the industrial segments. So I start with the home appliance. The home appliance is what I'm talking about is refrigeration, air conditioning and washing machines. This sort of washing machine we see in China at the moment being released. From the industrial side, we've got UPS, we have solar inverters, we have EV charging stations, and we have also inverterized welders. So going to the latest portfolio extension and the products, what I would like to speak to today. But as a brief introduction to the products, how I would like to just say is we have a naming convention for the IGBTs at Infineon. Here is a brief explanation of how the names are derived for us here at Infineon. So we have this IKW, so the I represents Infineon, where we come from. The K represents either the product has a freewheeling diode as a copack or as a single diode a single IGBT. And this slide is wrong. Okay, so then basically the next one is the package, which is for this case is a W, represents a tier 247 package. We also have a D, for example, which represents the D-back, the TO252. Then the next two digits that come into the name are the current classes. So here we always specify this at 100 degrees temperature on the case. The next one is an N, says it's an N-channel IGBT. The next one is the breakdown voltage, so it's a multiplication factor of 10. So here is 60, represents 600 volts, breakthrough voltage. And the final one is a couple of digits or letters, numbers we have at the back of the name, identifying technologies that we have. So in this example, we have H3, which represents the HighSpeed 3 third generation family. And moving to this HighSpeed 3 third generation family, so this family was released about 3 years ago. It's been quite a successful family since we've launched it. We've won innovation prizes. For example, the EDN Innovation Prize for New Products in China. We were awarded this. So what we have with this portfolio has been released, and this is an indication of an extension of this portfolio, which I explain a little bit further on and give a bit more detail. So what I would like to say here is we are extending the portfolio to larger current classes, going from 60 amps up to 100 amps. So 60 amps, 75 amps with and without a freewheeling diode inside the package, and 100 amps as a single IGBT device, which is the highest IGBT rated device in a tier 247. As you can see on this slide here, we've got samples and production dates identified. So the 75 amp device is now available for sampling, and here we plan to go with this extension into production in April 2012. The other family that I'd like to speak about here is for the home appliance market. This is this RCD family. We've extended the portfolio for faster switching frequencies now. So this denotes the F at the back of the name for fast switching. The 3 and the 4 amps have already been released. They're fully available for production on the market. And the 6, the 10 and the 15 amps are part of the portfolio extension. So here the 6 amp is available for sampling, and the 10 and the 15 amps will be available towards the middle of next year, with production around about June time is where we plan to go. Speaking a little bit more on this RCD, RCD-F, how did these fit together? So we released the RCD about 2 years ago. This is what we marketed this product for, was a space-saving device. It's a very high current class, up to 15 amps in a D-pack, so it's a very standalone device. We released this device after some feedback that came back from some customers in Korea, for example, and with this specification, we realized that it wasn't really perfect for the switching frequencies that the market moved towards. So we have the RCD basically optimized as a low VC-SAT device, so low conduction losses, but on the trade-off curve of IGBTs of the VC-SAT versus the turn-off losses, then when you move towards higher switching frequencies, this component of the switching losses was causing a penalty. So this is why we released the RCD-F family. This is denoted as this blue triangle on the trade-off curve. This represents around about a 61% reduction in the turn-off losses, so really optimized for faster switching. So here we've got a key differentiation, where to promote what, or where what can be used. So we say that the RCD is really ideally up to 5 kHz switching. This is in switching topologies like in-block commutation. The RCD-F, in comparison, is ideally suited from 5 to 30 kHz switching in, for example, a PWM switching topology, an inverter, for example. Additionally, what we have is if you go beyond 30 kHz up to 100 kHz, we've got the HighSpeed 3 family, which I speak briefly about in one slide. So the RCD-F and the RCD, how do these portfolios look together? So for the RCD, we've got the 4, the 6, the 10 and the 15 amps available in a D-pack. So the largest current class available on the market in a D-pack. And now this RCD-F family to complement the RCD in 3, 4, 6, 10 and 15 amps. The HighSpeed 3, as I was just mentioning, it was released 2 years ago. We've had several waves of releases onto the market. Maybe it's not always clear when the new products have been released, and this is why I would like to show on this slide the complete HighSpeed 3 portfolio that's available now. So everything where there's a green tick mark, these are available for production now. The 1200 volt device is a best-in-class device, and the 600 volt device is also classed as a best-in-class device. What we would like to show now, or what I would like to show now, is this portfolio has been extended again after a lot of customer requests for higher current classes from 60 up to 100 kilohertz, as I mentioned earlier. So with and without a freewheeling diode in a TO247 package. I would like to conclude my presentation. Thank you very much for spending a few minutes listening to this, and thank you for enjoying Infineon products.